And we are live. So, hello, everybody, and good morning. I'm really excited to be hosting another construction technology webinar today. And today, I'm very pleased to share that we have Ryan, co founder of INFR.ai, with us to share a bit more about extended reality, what that means for the construction industry, and some of the exciting things that they're working on. So, I'll now turn it over to Ryan to give an intro to himself for AI and take it away. So
Thank
Ryan,
you,
yeah,
Erin.
thanks for joining.
Yeah, thank you. Yeah, hi everyone. Thank you for joining. My name is Ryan. I'm one of the co-founders of INFR.ai, which I'll shortly show you on our slides. Some of you may know us as VR Collab. We do have some clients in the region, in your part of the world. But I think a bit more about myself before we talk about INFR.ai. I used to be a project engineer before doing this whole construction tech startup, being in this tech space. So during my time, it was the transition between 2D plans and BIM and a lot of technology coming on. Of course, fast forward to today, we have a lot of other kind of technologies, but I think the whole purpose and mission about INFR.ai is in 2024, what are the technologies like AI, XR, and some of these other both softwares and hardwares can we implement that to our construction lifecycle? Yeah. So allow me to share my screen. Erin, don't mind
Yeah,
let me know if you can see my screen.
it
Yeah,
looks good to me. One
it's
quick
full screen.
question.
Yeah.
Yeah, before we go into the presentation, I'm just curious. So you started as a project engineer. What sparked your interest in extended reality?
Initially back in 2016, I was thinking a lot of the idea of exploring designs before they
Hmm.
are built, right? So naturally, I had an inclination towards virtual reality. And during that time, it was it was a trending thing, right? So VR
Hmm.
was huge, and then we were loading our BIM models in. But what happened actually with VR Collab? Actually, when we started off with BIM to VR solutions, after a while, a lot of clients were saying, "We love your VR product, but are you able to create your product to be used without VR, with keyboard and mouse, but keep the same interface, the same graphics?" And then we were
Yeah.
thinking more about this, and then what we realized was that, oh, people were just looking for a way to better understand their designs, not necessarily experience them.
Right.
So that's how it all started. Yeah.
Got it. All right. Excited to learn a little bit more.
Thank you. All right. Should I begin?
Yeah, I guess one quick, I guess housekeeping reminder to the audience. So the chat and the comment section is open and available. There's going to be a lot of really interesting, cool content that will be shared here today. It's a great opportunity to ask questions, get really into the topic, maybe learn something new that you didn't know about before. So please feel free to use that comment chat box to ask your questions, leave some comments. We love the engagement and want to make sure that we're getting you involved in the content. So now, Ryan, I think it would be a good time to dive into it.
Definitely. Just to add to what Erin said, if because I have colleagues in the chat, so if you have any questions, feel free to ask. It's more of a conversation, right? Also do let us know where you're from, and then what you're currently, are you in a builder, a consultant, a
Mm.
contractor, so on and so forth. That'll be a bit easier for me to provide contextual answers to your questions, right? Okay, let us begin. So Infer AI, right? I know it's inference, short form infer, and without the e, right? So naturally, people would ask me, "Hey, why do you leave out the e?" Honest answer is that we tried to buy the full URL, but it was too expensive, right? So we found this URL, and I think it works, right? But previously on the top right, like I said, we were formerly known as VR Collab for around 6 to 7 years, since 2016, starting off with BIM to VR products, right? But of course, we have evolved in the past 8 years to what Infer is today. Bringing on many more technologies other than VR, with AR, with AI, and then of course a lot of integrations to hardwares and other platforms, which I'll share in a bit, right? So the way I look at things is that If you notice, right, in our industry, the architecture, engineering, and construction industry, in the past 10 years, I think the big shift has obviously been BIM, right? Back in the day, we didn't use BIM. We on our 2D CAD drawings, our plans and stuff like that. So, but now BIM is quite an essential part of many large projects. Where I'm from, Singapore, we have a BIM mandate for I think the past 10 years or so. So virtually every single public or private project is done in BIM. It's a necessary thing, right? And of course, BIM as a gateway into things like your common data environments, cloud infrastructure usage, which is quite funny, right? Because usage of clouds, let's say to store our documents, photos, we do that normally. We do that in our daily lives, but I think sometimes our industry, we are a bit of a laggard when it comes to these things that we normally do in our daily lives. So it's a bit of an irony, right? But for Infer, despite BIM and CDE and all these other things, what you will notice is that you've been spending a lot of money on technology in the past decade. Um, However, if you look at the trend, right, if you look at the past 10 years based on like your McKinsey reports, Autodesk reports, the rate of rework is not going down. So if you imagine a graph, like it's going up over 10 years, right? You're spending more and more money on technology, but your rate of rework over the project life cycle remains pretty constant or stagnant, right? Instead, what you should find if you spend more money, the rate of rework goes down. So naturally at INFR.ai, we're asking, okay, why is the rate of rework not going down despite spending so much money on technology? And then we dug a bit deeper, right? So much so that we have about 300 projects currently operating on the INFR.ai platform. And then we are asking our clients saying like, hey, look, before you embark on this project, right? Be it a residential, commercial, industrial infrastructure project, what is what do you think your rework costs? What percentage of the project value would you be setting aside, right? So for most builders, they would say anywhere from as low as 1% on a residential project up to 15% on like your fast delivery semiconductor factory kind of project, right? So on an average, about 10% of project value is set aside for rework. So I think for us, we are looking at it and saying, okay, that's really weird. You are using BIM and all these other technologies, but why is your rework cost still so high, right? The way we think about it is that, okay, let's talk about 2024, what is really happening. I think in 2024, we are able to have perfect design, right? So yeah, of course, you do your shop drawings, construction drawings. Of course, you have your BIM model. But this in 2024, it is possible to have designs that are free from both hard and soft clashes. So perfect designs, right? But even with perfect designs, when you go and build it, what happens? 5 or 10% of the manpower is designing the thing, but of the total project, but the 90% is supposed to understand it and build it. I think that's where that kind of misunderstanding or rework happens, right? So and the bad thing about it is that yes, we have a lot of new faces coming into the workforce. These guys are young, they're very technology savvy, great, right? And then the older ones are actually retiring. But then the issue with designing and building without technology is it's very dependent on knowledge and experience, which the younger folks coming to the industry may not have, right? So I think at INFR.ai, we want to use technology to help enhance or support that kind of influx of or changing of the workflow. And then hopefully we can translate the perfect design to even better builds, right? Okay, so one really simple question throughout the presentation, or at least for INFR.ai, what we ask ourselves is how can we ensure everything has been built correctly? So there are three main parts, at least we break it down into three parts of construction, right? So there's pre-construction, everything that happens in the design phase. So your architects come in, your engineers come in, you have your schematic model, so on and so forth, and then you go to detailed design. So that's all pre-construction, right? But the minute you break ground or you're doing a site survey, you're building on it, doing your piling, underground utilities, that's construction. And then, of course, after you've built anything, you should be wanting to check for quality or progress, right? So that would be post-construction. The reason why we break it down to three parts is because INFR.ai actually brings value throughout these three main phases in some of the ways that I'll be showing you, right? So first one, pre-construction, primarily design. Like I said, this is very similar to our first flagship product. You are able to bring in your BIM model for use, of course, in VR if you want, but 90% of my clients who use this part of the software, they actually use it with keyboard and mouse without VR. They use it to actually replace Navisworks or enhance Navisworks, right? So they bring in the model, and then not only visualize it, but one thing that they like about the software is we care about the interdisciplinary nature of the project. What you will notice is that many products that allow you to bring in the BIM model and visualize it in VR or not in VR, they are mostly visualization softwares. But for VR Collab or for Infer, we actually care a lot about the different traits, right? Your structural, your mechanical, and all stuff like that. And to be honest, as previously as an engineer, majority of the problems when you build a building is actually the MEPs, right? Your mechanical, electrical, and plumbing installations, right? Structural, architectural, not so much. Yeah, so this is the kind of effect that you can have. You can use it without VR, you can use it during your meetings, and then the other few screens, you can have your drawings and whatnot. Majority of our
Ryan,
projects, I think, yes, Erin,
question for me, Ryan. I don't know if you're able
yes,
to kind of go back a little bit to one of the points in the video. But I
yeah,
think it'll just be interesting to explain. So it's cool when it transitions from the model to everybody inside the room
ah,
looking at the, well, I know it's a cave environment, but could you explain a little bit more about like that experience here? Because I think this is something that maybe a ton of people haven't really seen or experienced themselves, but it can be super powerful. Could you share just a little bit about what's happening here in this snippet?
yes, definitely. So, what Erin mentioned as the cave environment is basically multiple 3D projectors or LED screens that allow you to wear glasses to look at it, right? Although we are operating in a cave, but you notice none of these guys are wearing 3D glasses. They're wearing their own glasses, right? So, um,
Right.
we have another video later on that shows cave,
Okay.
right? But the key thing here is that cave is more of an enhancement to virtual reality. So the great thing about virtual reality is that this lady, for example, who is wearing the virtual reality headset, she is experiencing the building one-to-one depth and perspective, right? So for example, what I mean by that is if she's this height in real life, she will be this exact height in the model relative to the model. If she takes a step forward, if she jumps or turns around, or squats down, it's the exact same distance of movement in the model. So that's a one-to-one kind of immersion, and it is accurate, right? But the bad thing about VR is that these two gentlemen here, her colleagues, her other stakeholders, is not able to experience the same depth and perspective as her. They are viewing her viewpoint on a monitor or TV. So that sort of breaks immersion. And number two, she is not able to see these guys, right? So that's one, right? But for caves, in order to allow everyone to have the same depth and immersion, but at the same time able to see each other, there is technologies like caves, right? So this is the cave video, which I'm about to show you in a bit. Yeah, okay, you guys can see it. Yeah. So this cave video, basically everyone who enters the cave, these are 3D projectors. Everyone who enters a cave would wear 3D glasses. Very similar to when you go to the amusement park or like some IMAX theater, you're wearing 3D glasses. The difference is that the content would be your design, right? It would be your future building, school, hospital, underground train station, what have you not. Yeah. So this is the kind of effect you can have. You can have one screen, two screens, up to five screens, six screens, all is possible. Um, what we notice is that at least in certain parts of the world, cave is becoming more popular. For example, in the Middle East, it's quite a huge thing. In over in Singapore, a lot of governments also have this requested in their tender. Yeah, but
Hmm.
the cost of something like this and the maintenance is expensive, right? But for Infer, our software supports BIM content on Cave or on VR or without Cave or VR. So that's like the key thing for Infer. Yeah, yeah,
Great.
yeah. So for this design portion, regardless if you're using VR, keyboard and mouse, Cave, the key thing that I think we bring value to is number one, we make coordination or understanding and communicating of the BIM data really easy, right? It's like playing a video game. I always joke with my clients like, hey, if you have a kid, right, who plays games, tech savvy, he or she could probably lead your coordination meeting with my software. That's what I always say,
So
right? Yeah.
funny story you mentioned, and I'll share it here with the group that's on the call. So back when I was at Suffolk running like the innovation lab that they have there in LA, we had a group of kids come through, and there was a 4-year-old, I think, that um, was in our VR system at the time and was able to just pick up the controls and was flying through the model like it was second nature. So I've seen that myself in real life. So yeah, it's very, very true.
Yes, it's
Very
absolutely
impressive
true.
seeing a 4-year-old navigate a 3D model in VR, but
But on the other side of things, right? Sometimes when I'm like presenting to really senior management,
Mhm.
right, they tend to be a bit older in age. So if someone try the VR, I say, okay,
Right,
let
right.
them try the VR. And then sometimes they get to the edge of a really tall building and they look down and it's almost a health hazard, right? Because they almost fall. So that's something when you use VR, you should look out for. Yeah. So that's that. But on the other side of things also is your design may be, there's no hard clashes, right? Like there's no pipes hitting walls. There no, it is constructible, yeah, to say the least, right? But is it accessible? Is it maintainable by the end users of the building? I think softwares like these and especially VR help you with that to see, okay, I've built a plant room, but am I able to, move around the plant room? Is this particular generator going to fit here? Outdoors, indoors, stuff like that. I think softwares like Infer can help you with that. So at least at this point in time, you have your design free from hard clashes. Doesn't matter if you're using your Navisworks, your Revistos, but as the final detailed check, design sign-offs, reviews, I think you should use softwares like Infer to ensure that, okay, it's constructible, buildable, but also accessible and maintainable at the final design. Yeah, right. Okay, so at this part of the video, before we go on site, right, you should have perfect design, right? So your 3D is perfect, your 2D is perfect, so on and so forth. And then this is the part where you go on site, right? So on site, to me, there are three parts. I mean, I used to be a project engineer, right? You can see me here, project engineer. So to me, I think there are two main parts. There's like the outdoor phase and the indoor phase. Some projects have one or the other or both. Most of them have both. Does not matter if it's a green field or brown field. So depending on if you're building in the city, you would know that your site, you would have a lot of these underground utilities, right? Underground engineering systems and stuff like that. So over in my home country of Singapore, we really dense country, right? So we have a lot of these like gas pipes, water pipes, electricity cables and stuff. Everything is underground, right? So it's very common that back in the day I would go to like as a project engineer, they would say, okay, Ryan, ensure that before we do our piling, I want you to ensure that the underground utilities, can you mark out where you're digging, not digging, what's the depth and stuff, right? Based on these 2D plans. But I think in 2024 with solutions like Infer, you actually can just take your perfect BIM model and then just overlay it on site before you have built anything, before you have dug the ground, after you have dug the ground, you would be able to see, oh, okay, looks like this, what's the second red pipe, right? Nearest to us. You click on it, oh, this is a gas pipe. This gas pipe belongs to this particular corporation or this government body, or it doesn't matter. There's a water pipe, there's phase one, phase two, phase three. If you click on something else, you can say, oh, this pipe is 2.4 meters below or 2.4 24 feet below the ground, does not matter, right? Yeah, so this information is at your fingertips. And on top of that, you are able to actually extract information that may not even be in the drawings that you have printed out, right? So for example, for whatever reason, I want to know the distance from the second pipe to the third piling, right, of this column. I can just click, on my iPad touchscreen or my mobile phone I can just click and get those drawing measurements, right? Yeah. So this is something that technology can definitely help you with. As an additional benefit, you get to see the structure, right, before it's built. So in this case, this project is actually a above ground train station. So it's supposed to span this road on the other side also. And then of course you move on to another kind of use case, which is more for like your formwork casting. So this is a greenfield project. There's no pipes underneath the ground. This facility is actually meant for trains to go there and then be maintained overnight, right? So of course you're able to, place the whole facility before it's built. But in this case, the builder actually used it for a very interesting use case. You see these train tracks in green, they're actually elevated on really like small concrete stumps, right? So before any of the workers are able to pour the concrete over the rebar to build these concrete stumps to form the former casting, right? The project engineer actually overlays the BIM model and then says like, okay, this orientation translation is correct. Okay, pour. So for every single one of these stumps, they do that. Of course, you have your survey, your survey points on the ground, and people are doing that. But I think relating it to your BIM and then overlaying it, you should have it's more of a double check. And it gets the project engineer also further involved in the progress of things, right? And of course, if things are translated or orientated wrongly, over kilometers of tracks, that creates a lot of engineering problems. So for this portion, these are like the two outdoor use cases for AR, the underground utilities and the formwork casting. So that is possible. Of course, you have all your information at your fingertips, so on and so forth. If you want to create an issue, take a picture, that will get synced up. But then I'll talk about that later. I'm just showing you more of like the fancier stuff, the more of the extended technology applications that you potentially may be able to use, right? Okay, indoors, the bane of everyone's existence, right? When you're building buildings, indoors, structure and architecture, facades are always fine, but that's where all like the mechanical systems, especially nowadays, I think we are building more and more hospitals, data centers, because aging population and we need more data, right? Space and stuff. So like critical systems, critical corridors. It's a massive headache, right? So indoors, very simple. Oh, I forgot to mention one thing. Some of you may ask, how are you overlaying this if I haven't built a wall? What are you doing? Are you using LiDAR? No, we're actually using the GPS of the device, so your phone or your iPad, right? But your phone or your iPad isn't accurate enough. Why I say that? So let's say you're driving down the highway, right? We're using your phone's GPS. It would be able to tell you roughly which part of the highway you're on, but you're not able to know the exact lane you're on, right? But with things like RTK receivers from Leica or from some other brand, does not matter. You can actually connect the RTK receiver to the iPad or the phone, the Android phone even, right? Via Bluetooth, and that makes the GPS of the phone really accurate. Within like, sorry, I don't know the imperial conversion, but it's about 2 to 3 cm. Yeah. So like maybe 1 inch difference, right? Translational difference in accuracy, and that would be good enough for us to overlay something like this with the GPS. But then when you go indoors, you're not able to use the GPS, right? Because GPS systems are not accurate indoors with, it's sheltered. You're blocking the signal to the satellite. So what you are able to do indoors is we use, let's say, the LiDAR of the device. So in this case, like the iPad Pro or the iPhone Pro, the software basically utilizes the LiDAR. It detects 3 planes, right? For example, the plane of this wall, this column, and this floor. These 3 planes mathematically would intersect at only one point in infinity, right? So we allow the user to select the same 3 planes in the BIM model, 1, 2, and 3, sequentially, of course. And then you're able to actually have this kind of overlay. And of course, once you overlay something like that, you are able to see like your your systems in overlaid on site. What's the use case of this? Before you install something, check before you install something, check other systems that have not been installed, but they are in the BIM design, right? So you can click on this red color pipe. What's this? Oh, this is the fire safety system that's going to be installed in 3 months' time. That should be in your BIM data, right? So for me as the project engineer or someone on site, the on-site personnel, I'm able to have these decision, have these critical data coming to me easily and making critical decisions, right? And then of course, after installation, let's say if I'm supposed to install this ducting and for whatever reason, I didn't follow the design, it's really obvious that you didn't follow the design. And I think someone should at least say why I didn't follow the intended design, right? We have noticed that previously a lot of like the builders and consultants like our product, but we have noticed an uptrend in owners taking an interest in this portion of our product for QA/QC, right? Before they sign off on like these 100-item lists before they pay up, right? They want to go through the site for critical systems and they want to use things like this. They just want to overlay the design because the design is approved, but your build is not approved. So if they overlay it, if it's somewhat similar, I think it's much easier to sign off. But if there's such a huge deviation from design and build, then I think there should be an explanation. Yeah, so that's something that you can, you should utilize in your construction. Yeah. That being said, this software of course runs on any iPad or mobile phone. It could be an Android or iPhone. There's a lot more features which I will not cover today other than AR. There are like your basic BIM viewing, annotating, creating issues, stuff like that. Of course, we are connected to not only Revit, Navisworks, but your ACC platform, so on and so forth. So for majority of whatever platforms you use in construction, we are integrated to them. And if you don't use them, it's okay. We have basic functionality to support you in your project, right? Okay, third portion of the third portion, right? Now that we have perfect design, we use the perfect design to understand and make critical decisions on site to help us build better and more accurately. Third portion, post-construction. After you've built something, you want to be checking. What are you checking for? Progress and quality, right? So this one, some of you may have heard of it. So for those of you that are already using 360 cameras on site, good job, right? Drones, whatever. This is not a drone footage. This is someone holding a 360 camera, like I have with me over here. Just walking through the site. What you will notice is that some people don't like to hold them. They attach it to their hard hat, right? At the top of their hard hat, they turn it on, connect it to their phone, walk through the site. What's the purpose of this, right? You may ask. I remember like many years ago when every time like I had to do this report, like my project director would say something like, "Hey Ryan, like for whatever reason, I need you to come out a report of this 20-story building and ensure that all, let's say, railings have been completed." I'm making this up, of course, because this is more related to the video, right? Every single portion of the building, make sure the railings have been built. So what I naturally would do is print out the drawings. I would go on site. I would take like multiple pictures with a camera. Back then it was a camera because phones were not good enough. But I would take multiple pictures with my phone. And then after work, I would, basically do some, spend a couple of hours in the office trying to translate like these pictures to this portion of the BIM or of the design or of the drawing, right? But with solutions or technologies like this, you can just get delegated to some people on site to say like, okay, I want you to walk from basement 1 to 5. I want you to walk from level 1 to 5, 6 to 10, so on and so forth every 3 days, right? Just turn on this Insta360. It's about the size of a GoPro basically. Connect it to your INFR app on the phone, and then what would happen would actually be these videos or images would actually be uploaded, and then we would utilize the AI to actually basically tag it or follow your BIM model, right? So if you're looking around, you are able to see the BIM model and drawings and stuff like that, right? Yeah, so this is great, especially for middle management, whereby let's say I'm a middle management, I would be like, okay, my 5 guys on site, this video was taken yesterday. And today, from the comfort of my office or home via the internet, I'm actually checking that, oh, this design is similar to what has been built on site. And this is part of site documentation, right? And of course, anyone can access this. It could be the project director, the manager, or even the client, right? The owner itself could be like, okay, this is documented. It's similar to what we sign off for the design. Great. You get your payment or whatever, right? So this is something that I think is really useful. Other than the AI portion of it, I think the hardware is really easy to use. So yeah, can take a look at something like this. Okay, moving forward, right? Everything up to this point is something that you can use on INFR.ai like today. For the next slide is more of R&D. Just want to share with you guys what we're working on. So the problem with something like this, right, is like, great, I have video or photographic evidence of the site that the railings have been built, right? But how can you be so sure that the railings are not too low, right? Like too tall, too high or too low? What is the tolerances based on the design? So with video or photos comparing to the BIM model, you can't do that, right? So what we're actually working on, we spent quite a lot of resources on this over the past year. We're actually trying to take your point clouds. Does not matter if you use like a static scanner or like this mobile scanner that this lady here is holding. Of course, with mobile scanners, you get a bit less accurate point clouds, right? So with just a generic point cloud of the or a scan of the area of the building, and since we have your BIM model, are we able to use AI to, number one, overlay it? After you overlay it, are we able to get the AI to say like, okay, run tolerance checks on every single BIM object, right? So so far this is what we have been able to do. The AI is able to say like, look, based on the point cloud, this two walls and this floor, we highlighted it in green. This is within, let's say, a tolerance that you set, like 0.1, whatever, right? This BIM object, this concrete shaft, it's exceeding the tolerance. So we highlighted that in red. And then of course the ones that are slightly transparent and monochrome colors, those have not been built. They exist in the BIM model, but not in the point cloud. So hopefully in time, we would be able to have a scan of your building. You would be able to have a scan of your building. Based on your BIM model, it will be able to tell you progress. So the colored ones versus the slightly transparent ones, and then quality, right? So progress and then quality, which would be how red or green something is, right? Yeah. Why I say it's R&D is because you will notice that a lot of the pipings, the ceilings, even this I'm not too sure what is this pipe here. We are not at least the AIs or the machine is not able to detect those with any certainty or accuracy. So I think there's something we have to put a lot more work into. Hopefully with better point clouds or better machine learning algorithms, we would be able to improve something like this. Yeah. So that's about it for a majority of the extended technologies throughout the construction life cycle. Yeah.
All right.
Yeah, I'm able to continue. I have a bit more of like ROI and talking about more technical stuff like certain hardwares. I think it would be slightly insightful. Should I continue or should we?
Yeah, let's
Give any
keep going for a little bit. I think we have the time, Ryan.
All
So
right,
definitely
perfect.
continue. So for the audience as well, we do have a discussion portion after some of the informational portion here. But again, just a reminder, feel free to put any questions, comments into the chats. Anything about extended reality is fair game. So this is a great opportunity to just engage.
Or AI is or machine learning is fine also. Yeah,
All
happy to
right.
answer that. Yeah. Yeah. So of course, naturally you would ask, okay, cool technology, what's the ROI, right? Everything is about the P&L, the bottom line, right?
Right.
Two main ROIs that we've gathered from hundreds of use cases or projects. For the consultants, or at least for the design teams, like your BIM teams, our flagship software, the one that I showed you, experiencing the building before it's built, checking for soft clashes, right? And of course, increasing understanding and communication of the design. This is the ROI. So um, um, based, I'm actually putting two companies there. So one is Hitachi Energy. Hitachi Energy actually is our largest European customer. They do a lot of like solar wind farms, industrial power plants, and that kind of project. And then we have the Land Transport Authority of Singapore. Basically, they're part of the government. They maintain like bridges over two different countries, roads, underground train stations. These two guys actually really love our software. They've been clients since like 2018, so maybe 4 to 6 years. What they noticed is that while utilizing our software, they were able to spot many more soft clashes as compared to traditional solutions or workflows like Navisworks, some other softwares. Even like, of course, you would do even better. We would fare even better if you were just using like your 2D drawings, right, to figure out what are the design problems, right? So, some basic calculations. If you think that a soft clash undetected and built, how much would that cost you, right? And based on that, how many clashes can you detect in an hour of using our software? And then, of course, design phases typically last anywhere from 3 months to a year or even longer. And how many hours of you using the software could potentially save you quite a bit of rework costs, because soft clashes were detected in the design phase and not being built, and only detected later when you want to hand over the building or halfway through construction, right? So this is more for the design kind of ROI. But I would like to say this, right? ROI aside, I think a lot of people that actually need to access the BIM model are not able to do so because, number one, they probably are not BIM trained, which is it's still a thing. Not to mention, I understand in many developed countries like ours, we are outsourcing our BIM development for whatever reason. So not many of us understand BIM, right? But we have to access because the critical data is there. So perhaps technology, you don't have to learn BIM, but maybe technologies like this could help you. You throw in the BIM, it's like playing a game, you understand what you need to do, you can communicate what you need to say, and then basically avoid the rework, right? For the builders and the crowd, this is a good ROI for you. So in this particular site, I actually put Obayashi, as you can see. Obayashi is actually the largest Japanese construction conglomerate in the world. They build, at least in this half of the world, they build a lot of data centers, right? So your Microsoft data centers, your Atron data centers are all built by Obayashi in this part of the world, right? So industrial projects again. So what happened was that this happened about I think 3 years ago. We were starting INFR, right? Like the really early version of INFR, because we were riding on the success of VR Collab. But when we were transitioning, I basically told one of the Obayashi project directors, like, hey, could we use this on your project, right? You just won the air trunk project. We want to use it for your data center. He was like, okay, why not? Let's try it out. Let's try it out for 2 years, right? Because we are building this in 2 years. And at the end of 2 years, I asked him, I was like, hey, how do we do? You guys seem quite happy using our platform. He was like, oh, you guys saved me quite a bit of money. And I was like, oh, how much did we save you? He said about 15% improvement in the rate of MEP rework. So I was like, 15% sounds good, but we only helped you, that there was never a time that this project didn't use our platform, right? So how do you know it's 15% improvement? So he was saying like, look, like at that point in time, Obayashi also won another project, a Microsoft data center, around the same size, about contract value about 332 million USD, also building for about 2.5 years. But they didn't use Infer, right? They used like a fragmented, your usual fragmented traditional workflows and stuff. So he was like, look, the other project, we actually did like 15% better than them in the rate of MEP rework. So he said, and as you know, MEP reworks are actually the only reworks that we face in data center construction, at least in this part of the world, right? So I was like, okay, good. Are you able to, break it down to time, minutes, or dollars? He was like, okay. While tendering for the project, Obayashi in this part of the world typically sets aside around 9% of their construction value. Sorry, the construction value towards rework costs. So I was like, okay, 9%. And if you guys save me 15% of the 9% that I set aside for rework, that's quite a bit of money, right? So if you do the math, basically, I saved him a couple of $1 million over the course of 2.5 years. Using the entirety of the platform, not just design, not just AR, not just the tracking thing, but the whole thing, right? Yeah. So I think there is a lot of the ROI for Infer when it comes to rework is actually just saving you costs that you already are going to, you set aside to spend on rework, right? So we're trying to bring some of that back to your P&L. And I think the good thing about it is that if you set it aside as cost in your P&L, if you are able to reduce that, then that actually straight away turns into profit, right, for the project because you don't actually you know, you don't actually you basically have a fixed sum that you're being paid. Yeah, that's what I'm about to say. Okay. I don't want to stay on this slide too long, but basically there are three modules for the Infer platform. There's the Infer web platform. It's a cloud-based platform, no different from your ACC and all these like Google Drives and stuff that you use. The difference is that the Infer web platform is actually more for your models, your issues, and it acts as the AI also runs there, but it also acts as storage and distribution to the other modules, right? So let's say for your Infer for desktop app running on your Windows or workstation computer, you're able to do your coordinations, your VR, the usual stuff. And then, of course, we are able to also bring back the issues that are done in VR or coordination back to the Infer web platform. And then, of course, we are able to also distribute and collect from the Infer for mobile app. So your Android phones, your iPhones, your iPads that you are bringing on site, you are actually able to go to your app store, your Apple Store or App Store, does not matter. Download the Infer for mobile app and then get all your documents and then use it with AR, without AR does not matter. Use it for the 360. And then once that information has been collected on site, you push it back to InfoWeb and then let the AI or whatever do its thing, right? That being said, at the top of the slide, you will naturally ask, okay, so what formats or data of mine do you bring in? Starting off, of course, your BIM and CAD formats, DWG, RVT, NWD, basically SketchUp, whatever you use, we are able to bring that in. Of course, for some of you, you would say, hey, like I'm using my Autodesk Construction Cloud or my BIM 360. I don't want to be, double uploading this one Revit file into two platforms, right? What can you do? No issues on that. We are directly integrated to ACC. So we will bring in your most updated federated model and corresponding issues into the InfoWeb platform, distribute them, collect it back, and then sync it back to your ACC or BIM 360 common data environment for your project. Other project data like your 360 video, photos, point clouds, PDF, Excels, all these we bring in. You can open them on the InfoWeb, but these is more just for storage. Yeah. And then of course, for each of the app, we are integrated to majority of your commercial off-the-shelf hardwares like workstations, VR devices, mobile devices, point cloud scanners, so on and so forth. Yeah. But we are more based on like if there is an open format to choose, like for example, point clouds, you have your proprietary formats like your dot FLS from Faro or like LGS or whatever, right? We tend to choose like the best open format one that everyone can export to. So in our case, for example, point cloud would be .las. Yeah. So if you have a .las file, you can just throw it on InfoWeb. You can actually view, and then some people say that it's like the smoothest point cloud viewer that they ever experienced. So try it out for yourself. Yeah. Okay. This portion of the slides, oh no, you have seen this video, but I'll
Yeah.
quickly, fast forward to some of the small snippets that you haven't seen. So we are working on, we actually basically building this bridge that is connecting to our neighboring country, Malaysia. So we're in these kinds of government projects. I can't show too much, unfortunately. This one you have seen. We are working on like airports, immigration centers. So AR, although I showed you more like indoor ones, smaller ones, but actually you can have very large scale AR overlays. Like this is an entire building, right? They're spanning multiple floors. There's like this overhang. You actually are able to see stuff like that. Then for some of you, especially if you're doing infrastructure, you're like, hey, look, like my site, for whatever reason, I don't have internet connection, or I'm like really deep underground, we don't have stable internet connection, right? For the mobile devices, are we able to use your software without internet connection? I to that I say yes. So how it works is that the software has an offline functionality. So while you're in the office or in the car, you download your models, your issues, your drawings, and then it will be cached and you can use it in offline mode. And then any issues like site issues that you're capturing, creating, it will be synced, it will be saved in the phone. And once you have internet, it will sync back to the Info web platform and then sync back to your CDE if need be. Yeah. So this is some of the use cases. This is the underground train station. This is basically the project manager checking on one of the project management team checking on some of the critical systems before he signs off on things. For those of you in the crowd that are a bit concerned about post-construction, right? What I mean by that is like facility management or A&A, additions and alterations. This is a real moving train, but we just happen to be overlaying the new wing of this station. And then the train moved past. So I think it's just a cool video to show. But yeah, nothing is being built. It's just an overlay using the GPS. This is another train station. They're actually gonna add additional like columns and then corridors or sorry, stairs and then the escalators and stuff. Yeah. So this is something that you can do. But key thing for FM is really simple. If you want to be viewing the hidden services in the ceilings, the walls, and the floors, you can actually do that really easily with AR. So that there is some use case for facility management, but but the value is not as much as for construction, right? Yeah. So this some of the use cases. You can have your measurements and stuff like that. Yeah. Okay, final recap, and then I'll talk a bit about like just want to tie it all together, right? So like I said, pre-construction, obviously, key thing you want to at least Infer helps you is with the understanding of the BIM, whether or not you're BIM trained. Even if you're not architecture engineering trained, let's say in a hospital project, some of your stakeholders are like your head of departments, your head surgeons. You bring them in, great. Use something like this. Once you go on site, utility survey, I think AR can help you with that, with the GPS. Forward casting, same. When you go indoors, MEP fit out without the GPS, the LiDAR camera. A lot of owners and even yourselves, you should use it for your QA/QC, your quality assurance and quality checks. And then of course you can use your 360 thing for site documentation. Hopefully we do the point cloud. We make some progress with the point cloud AI thing. And then you guys will be able to use that in the future. For like I said, facility management A&A, there are some use cases, but not as many as for the construction lifecycle. At least from design all the way until end of construction. Hardware really simple, right? Whatever workstation does, it could be a Dell, HP, Lenovo. We don't support a MacBook because MacBook does not have the GPUs to run it, right? But if you are just accessing the Chrome or like your web browser, you can access InfoWeb from there. Yeah. Like I said, iPads, iPhones, Androids, what have you not, you are able to use that. Okay, second last slide before Q&A. So a bit about Infer, right? So how we work is that some of you might be wondering, okay, so what's your business model? Really simple. I don't charge you via license. I actually support your entirety of your project. So let's say if you say, hey, look, industrial project 36 months, right? I would say, okay, here's a quote. And if you agree to that, for that 36 months, everyone who is related to that project, it could be from your organization, your other stakeholders, your owners, they are able to use it for this project. Basically unlimited users. There's no limitations on data. And then of course, I think it should be more than just gimmick, right? It shouldn't be a 1 or 2 day gimmick. It should be everyone on site is able to use it. Even if people do not want to use VR, AR, they should, we should be able to bring them some value, right, in their daily work. Like I said, hardware assets, buy as you need them. If you don't need them, pass it on to the other project. And then of course from our side, every single key person in the project will be onboarded by us personally. We have materials, tutorials, stuff like that. Of course, enterprise grade support, technical support, so on and so forth. And then within this 36 months, there's all ongoing feature updates are free and immediately updated. And then of course it operates via the web. That's really easy to update your apps, and the web itself, right? Yeah. So that's the end of my presentation. Look forward
Great.
to the Q&A. Yeah.
Yeah, thanks, Ryan. So I do have a couple questions prepped ahead of time here for you that I want to hear your thoughts on. So I'll first start with let's talk about all the different technologies, right? Like this is just one solution, and maybe just stop sharing the screen so we can see
Got it.
each other on the Zoom. I think the presentation mode kind of makes it a little funky. There we go. Cool. Yeah, so thanks for all that information. Why should contractors look at a variety of technologies to use on their projects as part of the project delivery approach?
I think it really depends. Why should they look at a variety of technologies? Um, I I mean the the natural answer would be like there's some value, there are pockets of value that you should be trying to capture, right? But the way I think about it, I mean, like I said, I previously was an engineer. I would just think about it like in a very human way. Like I remember being a young engineer on site, and I was like, some of these processes is one thing, right? But just the way processes and even products in construction are built, they're not very human. Like I'm not too sure how to put that, but there are much easier way to understand or do things, and I think technology should be able to help us do that. Yeah,
Mm-hmm.
so that's one thing. And like I said, like the subject matter or the context of construction is complicated enough as it is, right? So can't you make it a bit more human? Like if it's as simple as me putting together A and B, why go, do it in a very roundabout way? Yeah.
Yeah. Alrighty. So before I get into the next question here, this is probably, we're in the last couple minutes of the session. So if anybody in the audience has a question, feel free to put that into the chat now and we'll ask it. Otherwise, I'll move on. So I know you mentioned machine learning, artificial intelligence. It's been a big buzzword in the industry. And then extended reality technologies are no exception to that, clearly. So looking forward to the future and considering all of the AI capabilities that are flooding into the market, what can we expect or what should we prepare for in the industry?
I think for AI, at least the two major trends that I'm seeing is obviously you guys know about ChatGPT, large language
Mm-hmm,
models, right?
mm-hmm.
So although it's made for like language, but it's really good at processing like documents and stuff. So maybe that could help on the process side of things. That being said, AI, of course, the most common one is in construction now is 360, right? So at least in the US, that's a really good company that does solely 360 technology. They're called Open Space. They use SLAM-based algorithms, and SLAM-based algorithms are, this paper has been written like 20 years ago, but it's good that
Mm-hmm.
hardware is catching up to be able to implement that, very
Yeah.
in a very practical manner on site. And then of course, I hope at least that's what INFR.ai is doing, is that base at some level SLAM base can help with point cloud and BIM. Because if we are able to achieve that, then you're taking a lot of guesswork out and hard work out of the equation. Yeah, I think those are the three main ways AI potentially could help us. Right. And then of course for XR, to be honest, XR is still exciting and still could bring you a lot of value if you have not used it. But for those of you who have been using it for a couple of years now, I don't think XR can get any better than what I've just shown you. Um, I'm
Bold statement.
Yeah, yeah. So I think we have achieved like any incremental increase in the usage is exponentially harder to achieve. Yeah. So I
Hmm.
think we have saturated to that point. But AI, I think we still have a long way to go, and then we'll
Yeah,
see where it can bring us. Yeah.
just scratching the surface.
Yeah.
Alrighty, so we're in the last 5 minutes. Ryan, is there any, I guess, key takeaways for owners, architects, engineers, contractors who are using these types of technologies? Any last thoughts that you'd want to leave the audience here with today?
I think being an engineer, I'll give you very practical advice, right? So if you're not using BIM for whatever reason,
Yeah.
and you intend to be around for another 10, 20 years, then you better start using BIM.
Hmm.
Don't need to read up on Infer, because if you don't use BIM, I still could bring value to you, but not as much, right? But if you are already using BIM for a couple of years, you have an established team, then perhaps you could start looking into Infer or similar technologies. And I think for a lot of if you're not a consultant, let's say you're a you're a builder or owner, always start off with one project. Yeah. So just start off a project, ask for a pilot, do the pilot, see if it works for you. And then I think on the other side of the same coin, right, is that the technologies are there for you, but do you have the right people, like change management? Do you have the right people to carry out your pilots and stuff like that? I think that's even more important than technology. Because if you have someone who's if you have the right people, basically you will know the actual value that it could bring you. Yeah. So I think that's all I have to say. Yeah.
Yeah, love it. Give it a try, basically, and get into
Yeah.
BIM.
And then of course approach EKC, and they definitely can help you on that side of things. On the people side of things.
All
Yeah.
good. Well, Ryan, I think we are pretty much at time. I'm maybe keeping an eye out for a question, maybe one last one sneaking in. Doesn't seem like it. So at this time, I'll give you a big, big thank you. Thank you for joining us, spending your time sharing a wealth of knowledge about, your solution, obviously, but also just use cases in the industry and how these types of technologies can help make projects more predictable. And of course, all the other benefits, which is better safety, more predictable, or less rework, less costs, staying on schedule, all that good stuff. So thank you. I know it's late there where you are in Singapore, but really
No worries.
appreciate you
Yeah.
sharing with us today.
Thank
So
you. Thank you
yeah,
so much.
with
And
that,
thank you guys for attending.
yes, absolutely. So with that, we'll wrap up for today. And I look forward for the audience here next month's EKC Construction Technology webinar. So stay tuned for more. Thanks, everybody.
Thank you.